Hello, my friend. Welcome back to another episode of the podcast. Very, very good to have you here. I've, thought to myself that it's quite a crazy situation to explore. Anyway, as you might tell from the title, my guest today is talking about some interesting stuff, if you've already read the description, but I'll get to that in a bit, because the reason why it's also important is because maybe when you are listening to this, you're living in a place where the place that you thought you moved to or you live has a certain experience that drew you to it. I don't know where it may be. If you moved to America on work, or you moved to Europe because of university, or you moved to one part of India from another part of India, or you've gone, say, one of those people who moved for a, what was it called? The workcation, or the thing where they would mix. Like for instance, there's this fucking idiot who I saw in Goa but you can apply that to a lot of fucking idiots you see in Goa, and I use the word seeing very loosely. The reason I bring this one person up is because we were sitting at the shack in Goa, which of course a lot of people like to go to Goa for, and the various kinds of shack stuff where you can snort stuff off, snort other stuff of other people, or snort stuff off each other, whatever floats your boat. But this one shack we went to, I think it was in Mandarin up north. I think it was called Dune, if you're familiar with North Goa, which of course a lot of people are split, like, oh, I like South Goa, it's still untapped, it reminds me of old Goa. Like, they have these people, right? It's like, it's so quiet, and I get to feel my soul expand and my aura become a part of my soul, and I get sand in my chakras, those kind of people. And then you go to the north, like, I like the north, bro, because just totally vibe with the north, they sound different, they don't sound the same. Like, it's so amazing up north, like, it's like, I feel like I'm almost like in the north, just like away, one step closer to, like, I go there to do ayahuasca. I mean, yeah, they sound like the same people. Oh yeah, but they're split by the north and the south. Even within people who are awakened, you have the north-south divide. But anyway, so where was I? Yeah, so this guy, we're sitting there, and we were just having a beer, and it was very hot, as Goa is in the afternoons. And first of all, this experience is annoying as fuck, because there are these people who are so-called working there, right? Because they did that during COVID. They're like, I just realized that I can pick up my laptop, I can just move home, I can get a place to go, I can chill, I can work, and I can chill. But they don't do either, because they annoy the people who are there to chill, and they annoy the people who they work with. I don't know if they annoy the people they work with, but they annoy the people who come on holiday, who are just there to chill, because they're on their conference calls, they're not wearing headphones, and they're on these fucking video things, and they're loud, and they blur their background, and there's some other guy who's trying to be creative, come up with a strategy for his startup, putting Pink Floyd Comfortably Numb or Wish You Were Here, something to project to the rest of the people in the shack that he is totally so cool that he listens to profound lyrics from Pink Floyd. And I'm sure he's not listening to it because it's being carried away by the wind, and it's coming to my table. And of course, the waiter at the shack owner's place, he's playing his own music. He's playing fucking Honey Singh, as you do in North Goa. And there's a conflict of sound. And then all these people, if you haven't observed, are wearing formal shirts with whatever it may be, formal blouses, or they're wearing whatever formal attire that they have to appear in while attending their call, with board shorts. Motherfucker, how cool are these guys? They're walking around with their smartphones, and none of them have headphones, because what is privacy? What is consideration towards others in the shack? Nothing for these bastards, because, hey, I'm on vacation. No, I've moved from Bombay. I've moved from Delhi. I'm living in Seoul, bitch ass boy. I'm cool because I've found a hybrid model where I can chill on the beach, I can experience the coast, I can be one with Mother Nature, at the same time be one with C++. I can totally run my boutique. I'm sorry, they're total dicks. And then, as you might expect, it doesn't get worse. One guy rolls up with his husky. Yeah, that's what you do in Goa when it's fucking 36 degrees out there. You bring a dog from Alaska or Siberia, wherever it was originally from, to, okay, it's bad enough bringing it to India. Maybe some parts of India can handle it. Maybe some parts of Kashmir, some hilly places where it's cold. But bad enough you bring it to Bangalore. Maybe in Bangalore you have an air-conditioned house which you run the whole time, while you run the AC and you're on a call that going, yeah, climate change, we must have more greener initiatives at the office. But worse, one step, you bring it to fucking Goa. Anyway, you have these fools. So the point I was making earlier was that you expect you go to these places and all these guys sitting over there. And now suddenly, like Bangalore, is just constant rain. I like it. I'm sitting at home. I don't have to deal with the traffic. I don't have to deal with the potholes that are submerged, which you can disappear into. You don't have to walk down sewage-filled footpaths. I don't have to do that. That's why I'm saying it's nice. But it is awful. It is awful for a lot of people. And I don't understand how we can't really experience it. And I'm not saying education or qualifications, but it's just fucking obvious, right? So if that's the case, if that's our approach, fuck it. We'll just deal with it. You'll have some people who'll have these conversations like me, having these conversations on the podcast going, yeah, what is climate change about? And then you have other people who are just making huskies to fucking think. Maybe they'll be the same guy will be like, oh, I want to escape the weather and go out so monsoonish, you know, like my flip-flops from fucking Collective got all like fungus on it. So I'm going to go to like, you know, not dunes. I'm going to go to the real fucking sand dunes, bro, in UAE, because only UAE is the new Goa. I'm going to chill over there in their man-made lakes in the island in the shape of an Arab fucking sheikh's cock, and I'm just going to chill there at the head region because that's what I do. That's how I roll. I'm going to attend my con call. I'm going to be the next guy who's the next unicorn, and maybe you'll see real unicorns because that's coming to fucking gore you, you little shit. Or maybe he has a pet unicorn that he's got from some planet. Who knows? I'm just saying things that we expected from a place and we went to experience that place for what it had to offer is all changing. And that leads me very nicely, as I've gotten very good at, into my guest and who he is and what he does. It's Mr. Brian Toon. It's almost like I thought he's going to walk into the room. Brian Toon is quite a fascinating man with quite a fascinating career. 25 years at NASA. Now he's a professor of atmospheric and oceanic sciences. In the conversation today, we talk about, and I made a bit of a mistake up top, guys. I thought he was Colorado State, but he's University of Colorado. It's apparently a big thing. But anyway, so he, and that's how you know the conversation, the intro is recorded a little later. So we talk about how, you know, back in the 80s, he's quite pretty cool. He was an advisor to, on a panel, of course. I think he worked with Carl Sagan. That's who he worked with. I was going to say Carl Jung. No, he worked with Carl Sagan. You might be familiar with that gentleman's work. He was on my show last week now. And basically helped heads of state like I think Ronald Reagan and Gorbachev, Mikhail, you know, my friend Mikhail, with advice about non-proliferation, about the real threat of nuclear weapons and a resulting nuclear winter, about how these arsenals are pretty much lethal for humanity. So he worked in that capacity. Now he, of course, we talk about his understanding and how carbon emissions have the real impact, not just some person saying, oh, carbon emissions and footprint, none of that. He talked about what carbon actually does, how long it stays in our atmosphere, how long it stays in our oceans. He talked about some of the work he did early on with the ozone layer. Pretty much fucking fascinating, dude. Like at points I was like, I don't think I know enough to talk to this person, but he was really, really forthcoming. He was really patient, really, really informative. And as if you can hear, it's my baby girl crying, so I might have to go now. And all in all, really, really knowledgeable person. And he gives us a lot of information about the future, about what we can expect, about what's going on with the wars, and what realistically can happen if some country, like say for instance, in India and Pakistan go into a nuclear war. A lot of scenarios painted. A lot of them could come to fruition. Let's hope not. But before any of that happens, you must listen to him because he's a man who spent 50 years in this field and he knows a lot. So let's listen to someone who knows a lot as opposed to some so-called expert on some so-called news show, just fucking talking head, yelling because that's the only way he or she expresses their information. So thank you as always for tuning into this podcast. I appreciate you. I appreciate the effort you make, and enjoy this conversation with Brian Toon. Till next time, goodbye, God bless, take care of yourselves, catch you on the other side. Cheers. Mr. Brian Toon, welcome to the SoapyRao show. Thank you so much for joining me.
You're welcome. I'm looking forward to the talk.
You know, it's a very interesting topic that you have been focusing on for many years, and I want to get into that. But I want to also understand. So you're a professor at the Colorado State University, and you picked this topic.
University of Colorado.
Oh, sorry, University of Colorado. I'm sorry.
Yeah,
And
we're rivals with Colorado State.
shouldn't have said that. My apologies. So it's a very interesting thing, the university system in America, right? Because especially when it comes to sports like football, you have these leagues, you have the Big Ten, you have the Pac-10, and it's almost like it's its own culture, right? The subculture of the university rivalry, the university funding, and all these things. So how has it shaped up over the years? With now you hear so many conversations about campus, conversations about woke culture, cancel culture. I mean, for you, being a witness on campus, how is university, I wouldn't say politics, but the university sort of reflecting society?
Yes, well, I worked for about 25 years for the National Aeronautics and Space Administration, which is a government research lab, obviously. It explores the planets, but also does work on environmental science in the Earth. And then I moved to the University of Colorado. So I've also been here for about 25 years, which tells you something about how old I am. You know, and university culture is very different than the culture in research labs. You know, in the research labs, you kind of have one job, you do your research, you build groups that do complicated research problems, and you work with big facilities like satellite projects and aircraft. And in the university, it's kind of more of an individualistic thing. People have little research groups with students who work for them, and they tend not interact very much with other faculty. They might interact a little bit. And so it's a much more small thing. But you can do large things in the university by interacting with government labs and other things. I do a lot of work with NASA still, and as we're speaking, I'm involved in a field mission in South Korea that involves a NASA airplane, a high altitude aircraft, and a aircraft from the National Science Foundation, which is more of a business jet, and they're trying to explore how the monsoons over Asia transport material upward into the lower atmosphere and the stratosphere, and then it gets carried out over the Pacific Ocean. And so we're looking at what comes out when you are over Japan, for example, what's there that has advected away from the Asian monsoon, basically, which extends from Iran all the way across to the Pacific. So it's a major feature in the Earth's atmosphere. So anyway, then, you know, I have students who are involved in these projects, and they work at, I have one student, for example, who's working at a NASA center now, and other students are working at the National Center for Atmospheric Research, which is also in Boulder. And, you know, so the students, I try to get my students involved in larger research problems than just my own interests.
No, it's amazing that these things which we're studying as human beings, right? When it comes, you mentioned you worked at NASA, and now, of course, a lot in the news you hear about SpaceX, and you hear about these missions to various planetary systems, and now with the James Webb out there, you have these different images coming to our notice, and the information that we have access to is increasing. But you've of course done some amazing work as you know, part of panels. You've as you said, gone back 25 years in NASA, and you've really helped formulate a lot of policy when it comes to certain things that nations have experienced. But these two things that you focus mainly on, the atmosphere and oceans, which are the two fundamental elements, if you look at it, with things in the conversation we're experiencing which have changed, right? And when you talk about climate change, you talk about these shifts that we're experiencing. And I'm sitting in Bangalore right now, we're experiencing the monsoon, which is crazy. When it comes to certain patterns that a lot of people are like, we didn't have this 20 years back, right? So what is something that, did you ever think that when you chose this path to study and spend a lot of your life understanding, it would shape up such a large impact on humanity? No,
when I was young, everybody watched television shows from a guy named Mr. Wizard, you know, explored little interesting science things, and there was science fiction theater, which was little science fiction stories about the future of science. And of course, the Russians launched the first cosmonaut into space, and there was a big space race. And So when I was young, I would just had interest in lots of interesting little problems, many of which were solved after not too long. For example, when I was young, it was a big controversy about whether there were Yetis, which are supposed to be giant kind of people-like things wandering around in the Himalayas.
Yeah, yeah.
And it didn't take too long to solve this problem. People went up and talked to a bunch of monks who told them a bunch of fairy tales, and it finally just discovered that they were making up skeletons of Yetis and things like that from baboon skins or something.
Yeah,
and so we know that there are no such things as Yetis. But it's greatly disappointing to me that if you watch modern television, you'll see big stories about Bigfoot and other things like that. I remember a story on a science channel, which calls itself a science channel, about giant black cats. Of course, there are black jaguars in the world, and they were claiming there are black cats wandering around in the United States, and they might be dangerous. And so they had, all kinds of people talking about this. And then they finally brought a photographer out who said, well, yeah, I understand this picture right here of this cat. It's just a house cat, and it's a small little animal. It just looks big because of the way they took the picture. Here, see, here's another version of it. It's a cat. You would think that would have ended the problem.
Yeah.
But no, they continued the show, dropped the fact that this guy had shown it was a house cat, and continued on as if it were a mystery. To me, this is really bad. This is not the way that science should be communicated. There are facts. You can solve these problems, and you shouldn't just make things up because they're more exciting. I mean, it is true that it's entertaining. People like to hear about these things, so I'm worried about the way we're misusing these kinds of things to educate children. But at any rate, when I was young, there were all kinds of things I wanted to know about. What's it like on Mars? What killed the dinosaurs? What made ice ages? And, I read about all these things when I was a kid, and I thought, well, I want to know the answers to all these things. And so I kept trying to find some way to figure out the answers to all of them. And, I have been able to, in my career, look at what was on Mars and what's it like there. And we found ancient riverbeds, and we're all trying to understand how Mars would ever be that warm. And I was able to look into the extinction of the dinosaurs, which we know now was caused by an asteroid collision, and still debating about exactly what happened, but nevertheless, I think we know what happened. So the ice ages, I think we have a good idea about what caused them in a general way. So we answered a lot of problems, but it's a little discouraging looking back on this, that I'm still working on many of the same problems. In the 1970, I was working on Martian rivers and how to explain them. I'm still working on Martian rivers. So some of these problems it's really hard to make sure you know what happened.
And why is that? Because sometimes I'm not a scientist and I don't want to pretend that I understand what goes on in the science world or with academics, but it almost feels like with what you just said, with shows on, say, certain scientific so-called, as you mentioned, channels, it's almost like you're playing it up when in a time when we have access to so much more information. It almost feels like we're dumbing it down to bring up the drama. Why do you sense that happens? Is it to sort of confuse people? Is it to get more ratings and reviews, or is that sort of a trend across different disciplines?
I think it's just trying to make something entertaining and interesting to people. And if you solve the problem, you're afraid they'll lose interest. Like, how many stories can you have about Bigfoot and Yetis? If you say, well, we know they don't exist, then that you lose the whole topic to talk about.
But wouldn't that create more inquiry about new things? Sorry for interrupting, but the reason you mentioned Yeti and Bigfoot, but say we solve the Loch Ness Monster, Yeti, Bigfoot, whatever it may be, right? But now, I read the other day that they're finding these massive new existing sharks like the great whites growing up to 20 feet in these no fishing zones, because obviously there's no human contention. So these are new things that are evolving. Or also, for instance, you have these new footage coming out from NASA about these what's it called, the space unidentified objects in the sky. Yeah, so it's almost like there is a lot more to explore and be curious about, but we're still harping on the same issues and kind of being very narrow-minded about our view, right?
Yeah, there's so many interesting things out there that it's not like we're going to run out of mysteries and things that are
Yeah.
that are worth studying and understanding. And just to give you an example, I spent at least 10 years of my life working on the ozone hole problem.
Mm-hmm.
And so in the 1980s, a group of scientists on from the British Antarctic Survey they were sitting on Antarctica all by themselves, and they're measuring ozone overhead. And they said, "Oh, there's a huge ozone loss going on down here." And they called up NASA and said, "There's a huge ozone loss going on here." And NASA said, "No, there's not. We have satellite there. Nothing's happening." And they said, "Yes, something's happening." And NASA said, "No, there's not." This went on for a while. And finally, the British guys said, "Well, I'm going to publish a paper about the ozone hole." And so they did. And NASA went back and looked at the satellite data they had, and they discovered that it's dark there, of course, in the night in winter there. And when the sun first comes up, the satellite needed sunlight to make the measurement of the ozone. And so if they got a weird ozone measurement, a programmer wrote a line in there that said, "Well, if the ozone's really low, just throw the data out. It must not be any good." So they threw the ozone hole out. And
oh my God, okay.
Yeah, that was very embarrassing.
Yeah.
And so then they discovered that they'd thrown it out, and so they kept measuring again, and they still threw it out again because the programmer, instead of taking the line out, just raised the threshold, and the ozone hole was getting deeper and deeper.
Yeah.
So this was a huge controversy in science and in politics, what was causing the ozone hole. And we're fortunate that this was something that occurred just over Antarctica, because there's not that much light there and nobody lives there. And losing ozone is very dangerous because it can let ultraviolet radiation get to the surface, which causes sunburns and cataracts and cancers and things like that. Anyway, after this was firmly discovered, NASA and the United States and NOAA in the United States, as well as the British and other countries, so we have to go study this and figure out what it is. And this was the most satisfying science problem I was ever involved in, for the simple reason that there was actually a little contest before people started making measurements. What could be causing this? And so one theory was air was coming down from above, and it was full of nitrogen oxides that were created by sunlight. And the nitrogen oxides were eating up the ozone.
Right.
And then the second theory was that, no, the air was coming up from below. There's very little ozone in the lower atmosphere. And so if air was coming upward over Antarctica all of a sudden, then the ozone would go away, because air with the ozone would be replaced by air without ozone. And then
so it's being pushed out by this, replaced by this air from underneath.
Yeah, just be replaced. And then the third theory was, well, no, it's because of chlorine. And so earlier, about 10 years before the ozone hole was discovered, Sherry Rowland and Mario Molina had discovered that chlorofluorocarbons could destroy the ozone layer. And they predicted that in about 30 years from now, not even yet, about 30 years from now, that ozone would start to be destroyed at about 30 kilometers above the surface by chlorine compounds. And, they were very excited and worried about this, because
that's 30 years from today.
Yeah.
Okay.
In the future, not in the past, in the future.
Right.
And so they were very worried about this, and because chlorofluorocarbons are incredibly valuable compounds, they were used in air conditioning as a working fluid to make it cold, and refrigeration, and they were used in the foam that insulates things, and they were used in all kinds of industrial processes. So they're very safe chemicals, and they were very easy to manipulate and use for different things. So that's why they were very widely used. At any rate, most of the world didn't believe these guys, but the United States banned the use of these materials in spray cans. So like, putting hairspray on, if women used to put on hairspray on their hair, or deodorant or something like that. And they replaced it with things like butane, which is very flammable.
Right.
So I don't know if they do this in India, but in the United States, they have these little spray cans that are put out little streamers of rubber. And, you can spray these at a birthday cake with flames on it, with candles, and it'll make flames, which is very incredibly dangerous. So
it's almost like converting a kid's party into a flamethrower. Yeah.
Exactly, right. And so anyway, that was 10 years before the ozone hole was discovered. And when the ozone hole was discovered, the idea was, well, maybe there's something about the chlorine that's doing this instead of in 1980 and not in 2050. And so that was the third theory. And so we flew some airplanes down there, and we got there in August, and there was nothing happening. And there were a bunch of dynamics people, calculate winds, and they said, oh, this whole thing is phony. It's all just a bunch of winds blowing around, making things look like there's an ozone hole. And so all the chemical people were getting depressed. But anyway, eventually they started measuring things, and it started changing. And we could see there were no nitrogen oxides there. Yes, no. It was a yes-no question. Yes, were there nitrogen oxides? That'd be solar. No, it wasn't. And there weren't any. So that wasn't the answer. No. So the second question was the air full of air from the lower atmosphere? Well, then it should be full of stuff from the lower atmosphere. Made the measurement. It was a yes, no on that. No, that wasn't it. And then it got to be toward the end of September, which is when the ozone hole starts to form. And all of a sudden we saw all this chlorine in a form that would destroy ozone. And as it built up, the ozone went down. Yes. So that was yes. So there's three possibilities. There were two no's and a yes. The problem was solved.
Right.
That's, it got so bad scientifically that after about 10 years, Congress said, okay, this is boring. You solved the problem. We're cutting all the money off. Don't work on it anymore, even though we didn't completely solve the problem. So if you're a science person, it's not enough to just know it's chlorofluorocarbons and ban them. We wanted to know everything about it. And there was still things there we don't know about what's really happening, but we do know it's the chlorine compounds that are destroying the ozone along with some bromine. And it's a very valuable lesson was learned there, which is something important to know.
Does that happen a lot in your experience when there is something which has been diagnosed as a problem? Like let's take for instance, a lot of times there are certain as you said, like the chlorine and those compounds that help humanity, and you've probably seen a lot of things that have been introduced that make human life more convenient or modernized, if you want to call it, and then it's glorified for 10 years, and next thing it's demonized. Like plastics now are a definite no. You don't talk about it as a positive thing at all, because how it's affecting marine life, how it's affecting our lungs, and you have all these various compounds that are being released into the atmosphere. So how do these things work? Because sometimes, as you said, Congress will give funding for some research, then it's no longer convenient, or it's no longer relevant, or it's no longer getting the votes. Then they just move on to another thing. But as you said, it doesn't come to such a convenient conclusion in a scientific point of view. So how do you navigate? And I mean, how does it contribute to the problem? Because it might be something not as black and white or yes and no. It might be a gray area which says, yeah, it is bad, but it's also got some good. So when in context of the climate change problem, is it really that there are, say, three things are sort of the detriment of humanity and are going to be the end of our civilization, or is it much more complex than that?
Yeah, well, that's the problem with every other thing I've ever worked on, is that there are no yes, no answers.
Right.
They're all very complex. And so there is a fundamental link between the ozone hole problem, the carbon dioxide problem, and the problem with nuclear energy. And that is, how long does this material last in the atmosphere or the environment? So the problem with the ozone hole is that those chemical compounds were useful because they were very inert. Nothing destroyed them. And because they're very inert, they don't get removed from the atmosphere. They build up and build up and build up until they become a problem. And they have a lifetime of about 100 years, which is why the ozone hole is still there. I mean, it has hardly diminished. And it's not going to diminish until, the middle of this century, when finally these compounds should have been diminished. The problem with the carbon dioxide greenhouse effect is that carbon dioxide has a lifetime in the atmosphere, ocean system. So it dissolves in the ocean, and it comes to an equilibrium between the atmosphere and the ocean. And that equilibrium, is pretty fast. It happens within about 50 years or something. But then it stays in that system for tens or 100,000 years.
Oh, okay.
So if you put CO2 in the atmosphere today, for example, you drive your car or your motorcycle somewhere, or you turn on some natural gas powered heater, or you burn something to cook your dinner, that carbon dioxide, about 20% of that carbon dioxide will still be in the atmosphere thousands of years from now. So that's what the problem is. It's something that's got a huge time constant. Eventually it gets turned into limestone in the oceans, and so it gets turned into rocks like the White Cliffs of Dover, or I'm sure there's plenty of limestone in India and there, and there's plenty in China. So eventually it turned into rocks, but it takes longer than human beings, have even existed on the planet. So we're doing something every time we burn something that's going to affect the planet on a geologic time scale, longer than the lifetime of human civilization. So we can't keep doing this.
So what we're experiencing now with the water temperatures rising and the entire sort of conversation about climate crisis, which people are calling it, is it something that clearly it's not what we've done yesterday or today, but it's something that's done according to the timeline you just mentioned about 5,000-10,000 years back? Is that am I right when I kind of assume that?
No, this was started in the 1900s is when we started producing enough carbon dioxide to matter.
Okay.
So, people are always saying, oh, we don't understand the theory of what's going on. Well, the theory of what's going on was discovered in the 1880s. People understood in the 1880s the physics behind this. And they predicted that if you doubled carbon dioxide, it would increase the temperature of the planet by about 2 degrees. If you go with a big fancy climate model and you've got people that you pay $1 million a year for the group to run, they're still finding with the big models, if you're at double carbon dioxide, the temperature goes to about 2 degrees centigrade.
So we've known this for 140 years now, yeah.
Yeah, the answer hasn't changed.
Right.
But we have another question though. In the 1880s, they were interested in this because they're trying to understand ice ages. And in fact, the amount of carbon dioxide in the atmosphere has been involved in huge swings in the Earth's climate in the distant past of hundreds of millions and tens of millions of years ago. But they also in the 1880s said, well, how about people? Will people do anything? And they calculated how much CO2 people were producing. And of course, the 1880s population was much smaller than now.
Yeah.
And so they didn't anticipate that it would grow exponentially. And so they thought, in 1,000 years, people will be causing a problem. And so they messed up on how long it would take for people to cause a problem.
Yeah, it sounds like that ozone thing. A few people looked over certain numbers.
Right.
Yeah.
So, people are, the average American, I think, produces about 5 tons of carbon a year.
Whoa.
5 tons per American.
And that's about
so people say,
million.
let's bury the CO2. Let's take the CO2 and bury it. Well, I'm not quite sure how much an elephant weighs, but I think they weigh about 5 tons, which means that you have to bury an elephant for every person every year in the United States. Now, people don't realize the mass.
Sorry, what do you mean by bury? What do you mean by bury? Like
so
physically
say,
bury?
Let's take the carbon dioxide and convert it into some kind of rock and bury it.
Oh, okay.
And the reason you have to bury it is because if you just keep it around, this is like the problem with trees. People say, let's plant more trees. The body of trees is made of air, and trees are made mostly of air, and air and water, just like people were mostly water. Yeah. So you couldn't put the carbon dioxide in trees. Well, okay, somebody's going to come and cut the tree down in 10 years or something like that when they get bored of you taking up their land, and the tree will rot, and the CO2 will come right back. So if you want to get rid of the CO2, you have to bury it in the ground. That's where we got it from. We dug a hole in the ground, and we took it out of places where it had been buried millions of years ago in some totally different climate. It was buried underground as coal, or it was buried there as peat or some other organic. So we have to rebury it to get rid of it if we're going to do it that way. So the problem here is that if you take the weight of all the people on the earth, it isn't very much. For example, there's a volcano in the United States called Mount St. Helens that blew up in 1980, single volcano. It blew a hole in the top of the volcano with about a cubic kilometer of mass being thrown out of it. You can take everybody on the earth and stick them in the hole in the top of that volcano. So by mass, people are just don't amount to that much.
Yeah.
And of course, it wouldn't be comfortable, you'd have all the people piled on top of you. But nevertheless, however, people are like pond scum. So per person, there's about 2 football fields of land. So everybody in the Earth, you take the Earth's surface and you divide it up to everybody. Everybody gets about 2 football fields of land.
Right.
So now you've got 2 football fields of land, and you got your house to put on that.
Yeah.
And you have to put a little bit of ice on it from Antarctica, and you have to Greenland. You have to have some deserts there. You have to have your trash.
Yeah.
You have to have your crop and the cows or whatever other things you eat, all in this little plot that's like 2 football fields.
Yeah.
So now you have to take your 2 football fields, and every year you have to bury an elephant there. So you can see that this is not a practical solution to be burying all that carbon. If you have a lot of dead elephants there buried pretty soon. So that's why we have to do something about not putting more carbon dioxide in the air. We can't dig up more of it and put more in the air, because when we put it in the air, it's going to stay there for thousands and thousands of years. Our children, many, many grandchildren downwind, are all going to be affected by that carbon dioxide. It won't be removed on its own. It won't come out of the atmosphere by itself. We'd have to spend huge amounts of money to convert it into some solid form. We could convert it into limestones. There are chemical things we could do to take it out. It'd be very, very expensive to convert it into limestones. It'd take a lot of energy. So we could wait 50 years until we're totally miserable and put more and more CO2 in the air, and then pay a fortune to remove it. Or we could just stop putting it in the air now and save a lot of money, and we wouldn't be miserable in the next few decades.
So what will happen? Because, there's a lot of frenzy, and I suppose there is rightfully so in certain scenarios, because you said this is something that needs to be prevented, right? Like more coal burning plants, or more oil refineries, or whatever it may be, whatever form of carbon that's being put out there. But is there a scenario, because it is looking like it's just one of these things which is everyone's shouting about it, but how much real impact is taking place, right? Is it how much percentage is it dropping by the emissions of carbon? Because do you see a scenario where, because the reason I bring it up is I'm reading this book by Neil Stephenson called it's called I forget the word, Termination Shock. And it basically, if you're familiar with his work, he talks about futuristic doomsday scenarios, right? And the book I'm reading right now, it's almost like when I put down the book and pick up, like, say, open the app by The Guardian, it's almost like it's the same thing. It's not much different between what he's saying as a potential problem, because he talks about climate heating, talks about where temperatures are so hot, like, say, in Arizona or Texas or in Pakistan or India, where people are kind of compounding the problem by the solution, like they're turning up the ACs, but the ACs are adding more to the problem, so you have to do more air conditioning. So do you think that human beings will adapt to these increased levels? Like you said, our kids and our grandkids. Do you think the human genes will adapt to be more tolerant to more carbon in the atmosphere?
No.
Okay.
No, I think the problem here is that this is a slowly growing problem. We're going to see the repercussions of this for hundreds of years, probably, as ice slowly melts in the polar caps. So this is one of these things where the politicians have very short lifetimes.
Yeah.
Their horizons are a few years in the future. And, they don't want to disturb the people who select them. So they're not going to do anything to try to hurt people who are making a lot of money and who pay for them. That's especially in the United States. That's the problem, is you have all these wealthy oil people and coal people and things like that.
Yeah.
And, these problems are growing slowly. And so they said, well, let's just wait. The next politician can take care of this problem, who will then say the same thing. The next politician, they'll just pass the problem on. However, what's of concern in the science community is that there may be a point at which you can't recover. I mean, I've already mentioned that the carbon dioxide will stay in the atmosphere for thousands and thousands of years. Yeah. So the only way to solve that problem is to take it back out. Yeah. But we also have these massive ice sheets on the planet. And people don't realize how much water is in those ice sheets in Greenland and Antarctica. If they all melted, sea level would rise about 300 feet.
Whoa.
This is not a problem for me in Colorado because Boulder's at 5,000 feet above sea level.
I'm around there, Bangalore as well. So you and I, we can still keep talking.
Yeah, right. We're good.
Yeah.
There did used to be an inland sea here, though, before the mountains formed. Wow. The interior of the United States was all covered by an inland sea at the time of the dinosaurs.
Wow. Okay.
But nevertheless, we would lose whole states in the United States, and almost all the coastal cities around the world would flood. 300 feet, that's a lot of water. The entire states would vanish. So we don't want to melt the ice sheets. And that's what people are in the science community are afraid of, is that we'll lose control of the ice sheets and they'll start melting uncontrollably, and we won't be able to halt that even if we remove the CO2. And the reason for that is because there's the reflectivity, there's sunlight coming into the earth from the sun. And some of it is reflected by clouds and by ice back to space. And the part that's not reflected gets absorbed in the atmosphere and in the oceans and the ground. And
heats up, yeah.
And it heats the earth up. And the way that that's dissipated, that heat is dissipated, is that the earth is radiating energy back out to space. So there's a type of light called infrared light. And this is what they discovered in the 1880s, is that the amount of light that any object radiates is proportional to its temperature to the fourth power. So it's strongly dependent on temperature. So you're radiating energy right now, and I'm radiating energy right now. People sense this, and if you have a fire, the fire doesn't make the air warm. The fire is radiating heat towards you. That's why you put your hands out, in front of it to get your hands warm. Is the light is being absorbed by your hands. And, we're not sensitive to this as people because it's not like the sun, which is a point source, it's shining all of its energy right on you from a certain direction. But the infrared light's coming from all angles, coming from everywhere, and so there's a feeling called clammy, and that's because if you're in a room and the walls are cold, like you're at some European castle or something like that, then you're not getting as much infrared from the surroundings as you're radiating. And
so
that
that's the
feel out of
invisible
balance.
light that's warming us up, not the actual light that we see.
That's right. It's actually light. It's just you can't see it with your eyes. And this actually was discovered by Isaac Newton. I think he had a prism, and he separated the colors of, it was white light from the sun, but the prism separated the light into different colors. And so he put a thermometer into the different colors, trying to find out how much energy was in each color. And then he put the thermometer outside where there was no light he could see, and it was still getting heated. So there was obviously a type of light there that was carrying heat, just like all the other wavelengths of light, but you couldn't see it with your eyes. And there's a reason for that, which is that there isn't that much in the atmosphere to see with. Most of the light is in the visible. So that's why we were adapted to see that. At any rate, that infrared light is shining out to space, trying to keep the planet cool. And so on average, we try to balance the sunlight against the coming in against the infrared light going out. But the amount of sunlight is tapered or affected by clouds, which reflects them back to space, and by the ice. And so what we're concerned about, and what's happening in the Arctic right now, is the ice is retreating, especially the sea ice in the Arctic is retreating. And, so people can pay the Russians money and they'll let you sail across their sea without having to go all the way around through the Suez Canal or something like that. But that ice was bright and it was reflecting light. And
so now it's almost like we have lost reflectors.
We've lost reflectors because the ocean that they were floating in is very black. And so and that's why we can lose control of it. If the ice retreats and we get less snow, and there's not as much snow in the winter, and that retreats, and the snow is lost in the Himalayas, it may never return because now we're warmer because we lost that reflected light. And so that's what people are concerned about in the science community, is that if it gets very much warmer than it is now, in the next few decades, we're worried we'll go past a point where we can't recover, even if we remove the CO2, because the Earth will have responded by removing snow and by removing ice And, then it'll just be warmer and even
So
more
it's
ice.
become a giant absorbent ball as opposed to a reflective ball as well.
That's right. Right now, we're a pretty reflective ball. We reflect 30% of the sunlight back to space. But, it could be that, the ground isn't that reflective. It's only like 10% or 15%. So we could absorb a lot more sunlight.
So if that happens, and you said, okay, eventually we get to this point where 300 feet water levels rise. I read somewhere that someone said, oh, this is just a phase. It happens in the planet's history where we've seen temperatures go up more than this. And then it's a rise in the temperature before the big chill. We're going to see another ice age. Is that something you have studied, or is that just someone putting out their theory? Because you hear so many things. I just want to dispel it.
No, this is true.
Okay.
So in the last 600 million years or so,
okay,
which is a time that life is multicellular life has been on the planet,
right?
Which is not a very big fraction of the Earth's history. Mostly there's been algae and bacteria around.
Right.
At any rate, in the past 600 million years, about 90% of the time there have been no ice sheets, and the ocean has been 300 feet deeper. And so it's an anomaly to have ice sheets. It's unusual in the planet's history. So if you go back, 30 or 40 million years ago, there was no Antarctic ice sheet. There was nothing there for a really long time before.
So it was just an ocean?
Well, no, there was land. The dinosaurs were perfectly happy. There was lots of life. In fact, lots of tropics dinosaurs living in the Antarctic continent.
Oh, okay.
So it was much warmer. And life was spread out over the whole planet instead of avoiding the poles. So that's fine if you're adapted to it, but that's going to put New York City underwater, and lots of cities in India. It's a problem with property, in people's lives. And of course, the other thing is also true. So about 30, 40 million years ago, ice started to form on Antarctica, and it's a little hard to know what exactly what happened there, because continental drift. It used to be that Australia and Antarctica were kind of coupled together, and the ocean had to go around that big mass, and so there was a lot of heat transport by the ocean. But then South America separated from Antarctica, and Australia separated, and so now the ocean just goes around in a circle around Antarctica. So there's a current, so it's going around and around Antarctica. So it's very hard to get warm water down there from the tropics. And so Antarctica cools somewhat because of continental drift, opening the oceans up. And there's other things. At the time of the extinction of the dinosaurs, Central America didn't exist, and the oceans just sloshed back and forth between the Atlantic and the Pacific. At any rate, up until about 3 or 4 million years ago, this was a problem in Antarctica. But, they just kept getting cooler and cooler, probably because carbon dioxide was falling down this whole period. So if you go back to the end of the dinosaurs, 66 million years ago, the planet's been pretty much cooling steadily ever since then. And, so it's not just the position of the continents, it's also that carbon dioxide has been falling, which has caused the planet to cool off, because carbon dioxide is very good at warming the surface. So as I mentioned, everything is a radiator. And the reason you get the greenhouse effect is that carbon dioxide in the air not only does it radiate to space, but it radiates to the ground. And so you put more carbon dioxide up there, you get more radiation of the ground, it gets warmer.
So it's almost insulates the ground, Yeah,
we get an extra energy source. It's not just the sun, it's also the gases radiating down on us.
Right.
At any rate, carbon dioxide fell. And after about a couple million years ago, it got to be cold enough that we started having ice sheets advancing and retreating in the northern hemisphere. And we're pretty sure that the reason for that, or the ultimate reason for that, is the carbon dioxide levels fell until the planet cooled off somewhat. But then what happens is that the Earth's orbit is not really perfectly stable. The tilt of the axis, 22 degrees or so, moves up and down by half a degree or a degree or something like that, just a little bit. And this is what causes, so that the tilt of the planet is what causes winter and summer.
Right.
So they had a test of Harvard undergrads about why was there winter and summer. And they said, it's because the Earth is closer to the sun in the summer.
Yeah.
No, that isn't true. The Earth is not closer to the sun in the summer. It's actually closer to the sun during the summer in the southern hemisphere.
Right.
That's not what it is. What's happening is that the orbit of the Earth is, the spin axis of the Earth is like a little top spinning around. It's pointed toward the sun by about 20 degrees from the vertical.
Yeah.
And it bobs up and down a little bit. But it holds that position as it goes around the sun. So during the summer months, the North Pole is pointing toward the sun, which is why it's day all time there in the summer. And then in the winter, the North Pole is pointing the opposite direction away from the sun.
Yeah.
And so it's dark there all winter. And so this little motion of this angle there can make it colder or warmer at the poles, which it does every year between winter and summer.
Yeah.
And if you bob it up and down, you can make ice ages come and go. And we know this is happening because if you look at the periodicity of the ice ages, you can see the same periodicity of the orbit. So the Earth's orbit is egg-shaped, and it gets more and less egg-shaped, and this axis points up and down. And the time of year when it's spring along the orbit changes also. And those three orbital elements have definite periods over which they vary. And those same periods are found in when the ice ages are coming and going. So the last time it was like it is now on the Earth was about 100,000 years ago.
Okay,
And,
so there has been a time. Okay.
Yeah, about 100,000 years ago. And then there were a series of major cooling events. And the maximum cooling was about 20,000 years ago.
Right.
And then it started warming back up again. And, reached the kind of current temperatures a couple thousand years ago. There are all kinds of excursions about this where some really sudden bad thing happened. But by and large, it was just kind of, one cycle there, 100,000 years, bottoming out around 20 and then recovering. And we expected that same thing to occur again. So the period when it's cold or when it's warm doesn't last very long. It tends to last 10,000 years or something. And then you slide back off on one of these ice sheet advances. However, it appears from what people are calculating that that's not going to happen at the end of 10,000 years now. So we've already been okay for 2,000 years. We've only got 8,000 to go before we find out what happens. I don't think I'm going to find out myself personally.
Me neither.
People will still be here. Yeah. But it's predicted that actually, even without a carbon dioxide greenhouse warming, that the orbital elements are not quite right to drive us into another ice age. I don't have much confidence in this prediction because it's been this cycle of 100,000 years has been going on for quite a while, a million years or more.
So these are all man-made projections, as you just mentioned. So
it's a man-made projection, and I don't think we know that well. The climate models can't simulate ice sheets.
And as you said, orbital patterns, which is speculation, right?
Yeah. Well, no, we know the orbital patterns happen. We're absolutely positive those happen.
Oh, okay.
Because you can see them happening. You can measure these changes
in
the orbit of the Earth. And Mars is even worse. Mars tilts up and down by 10 degrees. And you can see evidence for huge variations in its climate as the planet tilts up and down. So we have great confidence that those orbital elements are true. And we couldn't send spacecraft people if we didn't know that really to places where we didn't know that really well.
I suppose.
We're sure that those orbital elements are changing, and how the Earth responds to that is very complicated. And right now we can run a climate model for, maybe 1,000 years or something, but the ice sheets, take tens of thousands of years to come and go. They're very slow, so we can't simulate the ice sheets interacting with the climate and the oceans yet. We just don't have fast enough computers. So
No, I mean, sorry, I didn't mean to interrupt, but no, I'm just understanding, like, you mentioned all the years, which you mentioned are all in the thousands, right? And we seem to be short-sighted, like, and you mentioned this understanding of the greenhouse gases and the warming we knew in 1880, which is 140 years back. And that's the smallest number you mentioned in the past 5 minutes. Otherwise, everything's 1,000, 10,000, 100,000, millions years back. So I want to understand, like, we seem to know a lot, and, there are a lot of yeses we know about, okay, this is for sure, but there's a lot of speculation, a lot of assumptions, and a lot of impacts which we don't know for sure. So when we can't really understand our own planet entirely, what is your position on what's going on beyond our solar system, whether the human species in its present form will be able to settle on a different planet with what Elon Musk wants to do, or understanding alien life, if we call it alien, but maybe life on other planets or in other systems. Is there something you can talk about, or is that something which you're not really concerned with?
Oh yeah, I've spent a lot of my career working on like Mars and Venus and exoplanets and things like that. So yeah, I think there's all kinds of interesting issues there. So we know quite a bit about the climate of Mars, for example, at the moment.
Okay.
And it's pretty darn cold there. It's about the same temperature as Antarctica. It's not going to be easy to survive on Mars, and doesn't have a magnetic field, and it doesn't have much of an atmosphere, so you get bombarded with radiation there. So it's going to be hard to exist there without getting cancer. So it's going to be a challenge to terraform Mars. I think the first thing people will do is that they'll go live in lava tubes.
That's subterranean?
Yeah, subterranean.
Right.
Because that will shield you from this harmful radiation.
Right.
I had a work with a friend who has done calculations as to whether there might be ice in these. So you could go into them and get water, and you could hide from the damaging radiation, just come out for short periods of time, and you could, seal it off and maybe make something habitable. And, I think that will go on for a while. Then we'll still start building big glass domes to live in or something. And so, I think that we will first move people to the moon and show that they can survive there for a while. And
we can survive on the moon?
Well, no, the moon's even worse because there's no atmosphere at all there. And, depending where you are, it could be really cold. And there's very little water there. People are excited because they think they've discovered some water that can hide out in craters where the sun doesn't shine on it. And so maybe there's some water we can use there. But it'll be hard to inhabit the moon. The advantage
so Mars is most promising?
Well, the problem with Mars is it takes a year to get there. Then you have to land. If something goes wrong, it takes you a year to get back. You're probably going to die. I wouldn't want to bet on the first couple of people who try this.
That doesn't sound like a fun Uber trip.
Right. It's not a good Uber trip. Yeah. But the moon, the moon's not very far away, a day or two, so you can go to the moon and try to build a habitat there and see if you can survive in it and figure out, can you grow food? And Mars, you're going to have to grow your own food.
Right.
How are you going to do that? Can you really do it? I can't even grow tomatoes in my garden. I wouldn't trust myself to grow enough food to maintain my life.
Yeah.
So yes, but there are some interesting things about this that have to do with the survival of species.
Right.
We tend to think we are immortal as human beings or something. But if you look at the geologic record, the average lifetime of a species in the geologic record is about 4 million years.
Okay.
The Earth is 4.5 billion years old. So the average species,
so that's not even 10%. That's is that even 1%?
Tenth of a percent.
Tenth of a percent, yeah.
Tenth of a percent.
Oh my God.
There are a few species like horseshoe crabs. I assume there's horseshoe crabs near where you live, and the oceans are pretty universal across the Earth. They've been around for a couple 100 million years.
Okay.
So there are some species that have been here a long time.
Right.
But the average is very short. Now, it's kind of hard to tell how long humans have been on the planet because there's, our species has only been on the planet about 100,000 years. So we haven't been here very long.
Right.
And, we're kind of odd because, the orders of life, you get the species is the lowest level, and then there's a genus above that. And most groups have various relatives in the genus, but we're the only species in our genus. But there used to be others, Neanderthals and Denisovians and things like that.
Right.
And, then there are all these other Homo and other sorts of relatives that are, more primitive that, been around for a few million years. So our ancestors have been around for a few million years, and monkeys have been around even longer than that. And so it's hard to tell when does our 4 million year clock start turning. However, my thought about what is going to happen to us is that we will indeed start going to other planets.
Okay.
And for example, we will start colonizing Mars. And somebody is going to go there and have children. And they're going to say they like it on Mars. Maybe they did good sunsets or something, they like the freedom.
Good
we tell them what to do.
Yeah.
Whatever. Why they go there, I don't know. They're going to have children.
Yeah.
Okay, so it's not too bad for us to go to Mars because the gravity there is about a third of what it is on Earth. So we're going to feel really strong.
Yeah.
It's like on the moon, the astronauts are leaping huge distances.
Right.
But if you are a Martian and you try to come to the Earth, you won't be able to move.
You won't be able to move.
You have a tough time. So those people are not going to come back. Their children will not come back to the Earth.
So their frame of reference begins on Mars. It's not like
right.
Yeah.
And so what's going to happen is this is the way species evolve. They become isolated from each other. And after a while, they develop different traits, and pretty soon they're no longer compatible. They can't reproduce together. They're separate species. And so I think the people who go to Mars will be the start of another species of people.
That sounds fascinating. Yeah.
Yeah. So you've probably seen like the Star Wars movies and things where they have all these bar scenes where there's, they're all sitting there drinking in the bar, and there's all kinds of weird other aliens there, like Jabba the Hutt, this big fat guy, and other mean aliens and stuff like that. I don't think that those are aliens. I think with those you're picturing there, those are all different humans. They're all different species of humans. And they came from some different planetary body where they evolved away from us and became a separate species. And that's why they can sit around at a bar and they can all drink alcohol and breathe whatever atmosphere is there. Is because they've adapted their planet, geoengineered their planet to be like ours, but they couldn't escape from the gravity problem and some other issues. And so they evolved differently.
That's fascinating.
So that's what I think is the fate of us. And it's probably not a long time fate. I don't know how long it will be, but it could be decades.
That's fascinating. Do you think we are a product of that from some other planet?
No, I don't think so. There are people who think that, there are meteorites on the Earth that came from Mars. And what happens is, an asteroid hit Mars, and we see this happen all the time. They hit Mars, and it blows rocks into space, and then the rocks come down and land on the Earth. And there's most of the asteroids we find on the Earth are some other place, but some small fraction of them come from Mars. And so lots of astronomers say, oh, well, if you go look at asteroids like carbonaceous chondrites, which are a very common asteroid, they look like a rock that's made up of all kinds of little pebbles. And so it's not homogeneous. It's got all little pieces to it. Yeah. And it's called carbonaceous because it's full of carbon. And they even contain various carbon compounds that are organic. And so they say, oh, well, that's how we came to be, is that stuff from space came and landed on the Earth and delivered all these chemicals to Earth, which then evolved to become people. I don't think that's what happened. I think the Earth it's much easier to imagine that these compounds form on the Earth than coming from space.
Right.
For example, a group just found that certain kinds of clays will take some simpler organic compounds and make RNA out of it. So our RNA is half of a DNA, and the RNA is capable of telling organisms how to make proteins. So the chemistry in the Earth's atmosphere has not always been like it is now. So before 2 billion years ago, there was basically no oxygen in the atmosphere. And it's still in nitrogen like now, but there was no oxygen to speak of. And so that's, half of the history of the Earth, there was no oxygen. It rose around 2 billion years ago, and probably around 600 million years ago, it got to be high enough to make an ozone shield and keep the Earth from being sterilized by ultraviolet light. So that's probably what kept life from becoming very complicated from 2 billion years. And well, life in the planet, as far as we know, is about 3.6 billion years old. And so for 3.6 to 600 million years ago, not much happened. There was just a bunch of algae floating around. Right. And, and then suddenly 600 million years ago, something happened. And all of a sudden, complex life forms occurred. And there's various theories about what happened. One theory is that, well, oxygen levels became high enough that creatures could metabolize with it. It's much more efficient to use oxygen to make energy with. And an ozone shield may have been developed that was protected some things. That's one theory. Another theory is that somebody developed carnivores. So before then, nobody was hunting you and trying to eat you.
Right.
And so you weren't motivated to develop defenses.
You're
and all of a
safe,
sudden, somebody started coming around trying to eat you. And so then you had to develop defenses.
Yeah.
And so that may have caused life to become more complex. The other theory is that there were several episodes around 600 to 700 million years ago when the Earth nearly froze over. So something happened to cause ice to extend all the way into the tropics. As far as we know, that there was ice over the whole planet. And of course, this is kind of a stable situation because it makes the Earth very bright. And so it's happy being cold. And we think that these things went away because volcanoes produce more and more carbon dioxide. And over millions of years, it built up in the atmosphere and got it warm enough to melt the ice and return things to a planet that wasn't totally covered in ice. So this is called snowball Earth. And it may be that the freezing over of the Earth stimulated life to become more complicated and complex so that it could deal with these extreme climate
kind of rise to the challenge.
Changes, an ice challenge. Yeah. So we don't know what happened, but something happened back in there. So life has a long history on the planet, but it also got stuck. And so it got stuck for, got stuck for 4 billion years and didn't really do much.
Yeah.
Then it, slowly started evolving. It still gets stuck. So for example, the dinosaurs, the dinosaurs arose about 250 million years ago after a mass extinction event.
Yeah. Yeah.
And they weren't the rulers of the Earth. There were things that sort of like crocodiles that were the rulers of the Earth.
Right.
And then about 200 million years ago, there was another mass extinction event. Both of these are probably driven by carbon dioxide fluctuating greatly and changing the climate. At any rate, then the dinosaurs took over. And so these two mass extinction events eliminated the status quo. Whoever was a ruler at the time got wiped out in the extinction and somebody else took over. It was the dinosaurs. And this is kind of an interesting thing. So dinosaurs dominated the Earth as large animals, but mammals dominated the Earth as little animals. So there weren't a lot of little dinosaurs. The little guys were mammals.
So what kind of mammals were there at that time?
Well, they evolved over time, and they were largely little guys or kind of mouse-like things. And at the time of the extinction of the dinosaurs, there were some mammals that were like a small dog around. And at the time of the extinction of the dinosaurs, a lot of them were marsupial kinds of mammals. There were different types of mammals than the ones that dominate us now. But at any rate, that's how we came into being the leaders of the planet.
Right.
It wasn't that the mammals outcompeted the dinosaurs. The mammals had been here, for 150 million years with the dinosaurs.
Went under the radar.
Yeah, we weren't getting anywhere.
Yeah.
It wasn't like we suddenly got up and started killing off the dinosaurs. They just stepped on us whenever they wanted to, and otherwise we hid in little holes.
Right. And that's how we probably survived the asteroid hit and all the various
Exactly. That's exactly what happened. And I wrote a paper about this once, and we went back and looked at the evidence for who survived, and that's who survived. If you were the type of creature that lived in a little hole, then you could survive a mass fire, which probably everything in the Earth burned when the asteroid hit the surface, and then it got very cold, and this didn't last long, maybe a decade or something like that. But the little guys had the advantage that if the dinosaurs probably burned up in the fires and they couldn't find enough to eat, and the little mice that were our ancestors, just went and ate a bunch of worms underground and waited for the smoke and the fires to clear, and then came out. And down where I live in Colorado, there's a very nice geological exposure where there's about 1 million years of history of the evolution of mammals.
Ah.
And you can see they started really little, and pretty soon they were like the size of a raccoon or a pangolin. I don't know if they have raccoons in India.
We have
Pangolin or
similar. We
something.
were just talking about this yesterday. We have similar kinds of things like bandicoots and other
Yeah,
kinds of
bandicoots.
rodents. Yeah, which are
Right.
pretty
So it took
not
about a
pretty.
million years for that kind of a creature to come out. But right after the extinction event, it was again crocodiles that ruled the world, and then for a while it was giant birds. So like ostriches ruled the world for a while. So we're a pretty recent invention here. We've only been around for a few million years.
And it looks like the roaches have a bright future.
A lot of people think that if we have a nuclear war, that cockroaches will be the dominant thing left on the earth. But
Interesting. I want to talk about that because you gave a talk about this as well. A lot of the things you've mentioned now are planetary, they're systemic, and in some context, we've adapted to the chemical composition or elemental disposition that we have access to, and we are what we are because of what has happened, and we are here today. But coming to things that are in our control, you have, as you mentioned, we spoke about nuclear war and nuclear weapons, and in the context of, you said, I think you have been an advisor and were on a panel that kind of gave recommendations to world leaders about 30 years ago, maybe earlier or maybe later. But I want to ask you, I want to go down this conversation before we wind up for today, is you mentioned that, okay, maybe we'll take it in a different direction. With the context of Ukraine and Russia right now and what's happening with Taiwan and China, can you just paint a picture of where we stand? Because it is pretty interesting how in some contexts people mention nuclear energy as something that can replace fossil fuels. But at the same time, it is incredibly disheartening when you look at the past and how nuclear energy, at least how uranium is being disposed and how it's being stored, and you look at what happened with the tsunami and in Japan, the nuclear energy, the spills and the damage as a result. So maybe can you just paint a picture of where we stand today with nuclear energy and nuclear weapons?
Yeah, sure. I'm not an expert on nuclear energy, but it has the same problems as carbon dioxide and the ozone hole. Nuclear radiation has a lifetime that's tens of thousands of years or longer. That's what I don't like about it. You start building reactors all over the place. The building lasts 100 years, and you've got to bury the reactor. And you've created all that waste. There's 100,000 tons of waste around the earth now that's radioactive. And it's going to be radioactive for thousands of years. So I think that's a difficult path to take unless we find some other cycle. But, I'm optimistic that fusion will be understood in the next few decades. And, fusion will solve huge problems because it doesn't produce a lot of radioisotopes as far as we know, which we don't know because we haven't controlled it. But if it isn't producing long-lived isotopes, and it could eventually power the Earth and also get rid of the trash problem, because you just throw all your trash in there and it'll reduce it back to elements, and you can pile the elements up and make other stuff out of it.
Oh, that would be lovely.
That'd be great. Solve two problems at once: energy and trash.
Right.
But nuclear weapons are a different situation. And so I got into this problem of nuclear weapons because of the extinction of the dinosaurs. When that was discovered in the early 1980s, we said, wow, well, what happened there? And what happened there was that the asteroid started everything on the Earth on fire. And there's a layer, you put your hand on it, and in most places on the Earth, I can go down southern Colorado, there's an exposure, you can touch it. The layer that's got the asteroid in it, and also in that same layer, there's smoke, 66 million year old smoke. And
that's in our topsoil, you're saying, in the top layer?
No, it's in a geological strata, so depending on where you are, like where I am, it's exposed in this place where some erosion has exposed this ancient land. And other places is buried, so you have to go to a place where it's exposed.
Right.
At any rate, like India, the Deccan Traps are about the same age, which is a bit of lava flow in India. At any rate, we know that there was a global fire there, because to make that much smoke, you had to burn everything on the planet. And so we were modeling this, trying to understand what this did to the dinosaurs, which of course they mostly burned up in the fires. but there was also 75% of the species on the planet went extinct along with the dinosaurs. So there's a mass extinction in the oceans, which isn't going to care about fires.
Right.
But what happened there is all this smoke in the upper atmosphere blocked the sun from reaching the surface. The phytoplankton couldn't reproduce anymore. They all got eaten by the zooplankton and the fish, and the food chain collapsed in the oceans. So they starved to death in the oceans. And so we were looking at nuclear weapons and thinking, well, wow, the same kind of thing happens when you explode a nuclear weapon. If you look at Hiroshima, for example, from the Second World War, there was a nuclear bomb that went off there, killed about 100,000 people and very quickly. But it also started a fire in the whole city. The whole city burned. That energy release from that fire was 1,000 times bigger than the energy release from the bomb. So these fires are incredibly energetic.
Right.
And there are pictures of the smoke from this fire, which went up to the stratosphere. And that matters because in the lower atmosphere, if you have a fire, a forest fire or something, the smoke tends to be pretty low.
Yeah.
And next time it rains, it gets washed away. So it stays in the atmosphere for a week or something like that.
I mean, it's bad for carbon levels, but it can be at least immediately washed away. Yeah. Yeah.
It can be immediately washed away. But if you put it in the stratosphere, it never rains in the stratosphere. The stratosphere is kind of where commercial airliners fly.
Yeah.
And they fly at the very bottom of the stratosphere. So if you put it above where commercial airliners fly, it'll stay for a couple of years. And what we predicted in models in the 1980s is the sun would heat it, because it's black.
Yeah.
And it would rise even higher and go very high in the atmosphere. And we've actually observed this in the last few years. There have been 2 massive fires. It did put lots of smoke into the stratosphere, and it rose to very high altitudes because of the sun shining on it. So we can see that part of the predictions from these models is true. So we have this situation now where we know what happened to the dinosaurs, which we think was a mass fire globally. And we have forest fires, which are just barely doing things to change the earth. And then we have attacking every city on the planet with nuclear weapons. Okay. So
sorry, you just mentioned, so the wildfires we're seeing right now aren't, I mean, of course it's bad, but you're saying it's not going to have the global impact that the fires that the asteroid strike had or like Hiroshima had.
Right. So the amount of smoke. So we think a nuclear war between the U.S. and Russia and NATO would put about 150 million tons of smoke into the upper atmosphere. Whoa. 150 million tons. But we think at the time of the dinosaurs, there were 15,000 million tons. And so there was 100 times more smoke at the time of the dinosaur extinction.
Right. Okay.
These little fires from in British Columbia and Australia in the last few years, they put in about 0.1% as much as we think would come from a nuclear war. And so we have examples on either end of the problem, natural examples that we know something about, but in the nuclear war, you can't do that experiment. Science likes experiments and observations. We can't do that. So we don't really know exactly what would happen. It depends on modeling. But there are several things that are worth knowing about in this. So right now, Russia and the United States have about 8,000 strategic nuclear warheads that are either deployed. They have about half of them deployed and the other half in storage. 8,000. There are only 200 cities in Russia with 100,000 people in them. There's only 300 cities in the United States with 100,000 people in them. There's 500 cities with 100,000 people. There's 8,000 weapons. That's 16 nuclear weapons for each city with 100,000 people. This isn't that much different between Pakistan and India.
Yeah.
I think Pakistan has 60 cities with more than 100,000 people.
Yeah.
And India right now has 150 nuclear weapons, we believe.
Right.
So it could bomb each Pakistani city
at least 3 times.
3 nuclear weapons.
Yeah.
It's not quite equal because there's like 450 cities in India with more than 100,000 people, and Pakistan has got 150 weapons. So it doesn't have quite enough to bomb all of them.
Yeah.
However, Pakistan is rapidly increasing its arsenal. We believe by the end of the decade that India and Pakistan will each have more like 250 weapons, maybe a few more. Some people think Pakistan will be the third largest nuclear power in terms of the number of weapons that they have. They're probably trying to go to 450 so they can bomb every city in India. Or who knows why they're choosing these numbers. It's an irrational
What would
thing.
happen, because you mentioned what happened with the bomb that was dropped on Hiroshima, right? But what would happen, like, and what is the power of one of these bombs, which say India or the US or Russia or NATO or Pakistan have?
Yeah, so we don't know what the yield of the Indian and Pakistani weapons are because they're not controlled by any treaties. And, the last test was in 1998, so we don't know from tests what they have. But, it's North Korea developed a couple hundred kiloton weapon in a couple of years, probably because Russia and China, one or the other, told them what to do.
Right.
So we don't know. China, India, and Pakistan both claim to have higher yield weapons, but who knows if they have them or not? We don't know.
Yeah, yeah.
So we've looked at what happens if you explode one weapon in an Indian or Pakistani city.
Right.
And so in certain cities, so the smallest nuclear weapon on an American submarine is 100 kilotons. So that means it has the explosive energy of 100,000 tons of conventional explosive. So you can imagine you can't put 100,000 tons in an airplane.
Right.
That's why nuclear weapons were made. They were made to destroy cities with single weapons. So one of these bombs can destroy an entire city and burn it to the ground. And, so depending on what city you attack, if you attack New Delhi or a highly populated city in India, you're going to kill, hundreds of thousands of people, at least in, I've forgotten exactly the number of different cities. The last time I did this was Hong Kong, 100,000. You could kill 1 million people in Hong Kong with one weapon with 100 kilotons of yield.
And that's just with the bomb, not with the
with the bomb.
Yeah, right.
So we predicted, if there were a war between India and Pakistan that used 50 weapons of each side of 5 kilotons or 15 kilotons, which is a Hiroshima-sized bomb, and which is the size that both countries tested.
Did you say 15
on each
kilotons?
side.
15 kilotons.
15 kilotons. That you probably kill something like 50 million people.
Whoa.
Between the two countries. On the other hand, if you had 100 kiloton weapons, and you used 150 of them, no, you used 250 of them.
Right.
So we're hypothesizing that in a few years, there'll be 500 weapons between India and Pakistan, 250 each.
Yeah.
And we think India won't use all of theirs. They'll want to hold some back because they want to keep China out of it.
Right.
And so they wouldn't use the whole arsenal. And they use some of them to attack military bases where there's not much located there. But we hypothesized 250 nuclear weapons would be used in cities in India and Pakistan. And depending on the yield, is it 15 kilotons or is it 100 kilotons?
Right.
Depending on the yield, either 50 or 150 million people would die almost instantly. 50 to 150 million people. And so more people would die in India, but India has a bigger population, so a bigger fraction of the Pakistani population dies. But nevertheless, it's a disaster for each country. And that's not the worst part of it. So what happens is that the amount of smoke, I guess, depending on your point of view, what better means.
I mean, it's I'm sure the cockroaches are like, the
cockroaches are all for this. They're
listening to this podcast going, I like this. Go on.
So we believe the amount of smoke that would be generated in a war between India and Pakistan would be somewhere between 5 million tons and about 50 million tons. 5 and 50. So it's less than a U.S.-Russia war, but not that much. It's maybe a third as much, but that's still a lot of smoke. Okay. And so what happens to the smoke? It goes upward because they'll generate these big thunderstorms from the fires, which are incredibly intense. And that'll put all this stuff into the stratosphere. And so this whole chain has been observed, going from burning something like a forest and going to the stratosphere. So we know about that. But we don't know how much fuel is in Indian cities and Pakistani cities. There are a lot of uncertainties in there about what's there, what will burn. But nevertheless, if it does go into the stratosphere, it spreads over the whole Earth within a very short period of time, a few weeks, because it heats the stratosphere to 50 degrees centigrade, which incidentally destroys the ozone layer.
Right.
And so you just really destroy the ozone layer, and which lets all kinds of ultraviolet light get to the ground, which we've never experienced in human history. We have no idea how the biota will respond to that. They probably wouldn't like it. And you probably wouldn't be able to walk outside of your house for very long without getting a bad sunburn, tens of minutes or something like that. So anyway, that's bad. But the worst part of it is it stops the light from reaching the surface of the planet, which is what happened with the dinosaurs and the asteroids. The sunlight was cut off. With the dinosaurs, we think the sunlight fell to a level which is 100 millionth of normal, 10 to the minus 8, 100 millionth. Surprisingly, people can still see like that. That's the side of a moonless night. Your eye is not linear. So cameras are linear. Your eye is logarithmic. And so you can see tiny, tiny amounts of light, whereas cameras can't, which is why we have trouble taking pictures of things. They don't react like your eye. So anyway, at 10 minus 8, birds could still fly around, and probably did at the time of the extinction of the dinosaurs and hunt and stuff, but it'd be pretty dark. U.S.-Russia war, we think there'd be about 30% of the light would be left. In the war between India and Pakistan, it'd be 90% left to maybe 50% left, depending on how big the weapons are.
And this would affect everything, right? From agriculture to...
Absolutely. And so what happens, we know exactly what happens when the light goes down, because it happens every day. It gets night, it gets cold. Okay, no mystery there. What happens in the winter? The sun is, the pole's not tilting to the sun anymore in the northern hemisphere. We lose light, it gets cold, it starts snowing. So we know exactly what will happen. This is totally within the range of climate models to simulate, because they simulate the day and the year all the time. And so in the worst case, which is NATO, Russia, US war, you get what's called a nuclear winter. And so what the definition of that is, if you go to some place, a grain growing region, so we looked at the Ukraine and Iowa. So Ukraine's a big grain growing region in Europe and North Africa, and Iowa's a big grain growing region in the US. And the temperatures start falling soon after this war. Within a month or so, it's below freezing in both places. There's not a single day for 2 years in which the lowest temperature of the day is above freezing. So
2 years
below freezing every day for 2 years. You're not going to grow anything at mid latitudes.
That's
it's still warmish in the tropics. You could still, in fact, India does okay with this, except the fact that everybody's dead from the bomb blast. But you're a little more tropical. It'll still be okay, warmish there. But this kind of a war is going to destroy all the transportation and everything else. So this is something people don't realize. It's something people don't realize is that, at least in a lot of the world, people have either read the Bible or they've read the Quran. And they both have the same story, which is about Joseph and the Pharaoh of Egypt. And so the Pharaoh of Egypt is having dreams about cows. And so he dreams about 7 good fat cows and then 7 skinny cows. He doesn't know what this means. And so he goes to talk to Joseph, who's a prisoner in the jail. Why in the world does he talk to Joseph? It doesn't make any sense. But I guess Joseph's interpreting dreams of prisoners, which is probably pretty bad.
He had a good rep in the prison.
What does this mean, the Pharaoh says? And Joseph says there's going to be 7 good years and 7 bad years. So you should store up grain for 7 years. And then you can feed the Egyptians for 7 bad years. And so in the Bible and the Quran, the Pharaoh does this and becomes a big hero, Pharaoh. And of course, he's got a term of 15 years, which is longer than any president or other leader in the current world. But at any rate, this is just not true. The current world has enough grain in storage for 60 days, 2 months. After 60 days, everybody's starving. And so why doesn't this happen all the time? And the reason for that is transportation. So in the modern world, a modern city only has enough food for about a week in
My
hand.
God.
And so if something happens, to isolate a city, all the food's gone within a week. And then people have to bring in more food. If they can't do that, then people are going to starve.
We saw it happen in Sri Lanka. I mean, as we speak, it's
Sure.
I want to ask
happened.
you. I mean, it's quite crazy just hearing all these models and actual calculations. But you mentioned something earlier that how a lot of these things can't be put right because politicians have very short-sighted views and they just 4-year terms or 3-year terms or whatever it may be. But at the same time, a long standing leader, like say a Putin or someone who's been there in power for, or a despot, I mean, some of them turned to be despots, but like an autocrat for 20, 30 years, the problem is what happens then is the power goes to their head, or they end up making decisions like what's happening right now, which so it's kind of like short-sighted is not good, but they're in power for too long, then they end up getting these ideas which not always end up well or end up doing good for other people. So you mentioned something which was how but 30, 40 years, world leaders were warned against this entire situation, the scenario that nuclear war can create. And they put measures in place to kind of reduce tensions, reduce the arsenal that's being built. Sitting with the leaders today and seeing the mindset of people with social media, with information, with all this polarizing conversation going on with the left and the right, with everything being so extreme on either end, what is I mean, since we spoke about the positives with the war and not the positive, but all the scenarios that are playing out, what would you say with all your experience, because you spend a lot of time in this space, in this field, and you've given a lot of people advice, what can we expect with, say, the Russia-Ukraine war, with NATO, what's going on, with everything, with resources being delayed, with a lot of the things that you said, some of it has come to fruition right now as we speak. So what is something you are looking at the news every day, with all your knowledge, with all your experience, with all the years you've spent, and what is the next, let's say not even a year, the next few months looking like?
Well, let me backtrack for a minute to the 1980s.
Yeah.
So at that time, I was working with Carl Sagan, who happened to be an incredibly good communicator of science to the public. And so he was very well known. And when we discovered this nuclear winter thing, Carl told everybody about it in sight. And at the time, Ronald Reagan was the president of the United States.
Right.
He was kind of a Trumpian figure. He was very much like Donald Trump, except that he could complete a sentence and wasn't totally addled. But he appeared to people to be extremely dangerous, and people were afraid he was going to start a nuclear war. And then in Russia, the leader was Gorbachev. Right. And the Russians, of course, blame partly for the end of the Soviet Union. Right. But at any rate, Ronald Reagan actually wanted to get rid of the nuclear weapons on the planet all of his life. He thought they were terrible. Right. And so did Gorbachev. And so in the mid-1980s, there was a furor going on around the world because of nuclear winter, and people telling everybody that a nuclear war would kill everybody in sight. And, Carl was able to communicate this very clearly to the Congress, and, Ronald Reagan understood it. He and Gorbachev reached an agreement in 1986 to eliminate short-range missiles in Europe. Right. And before doing that, Reagan said, scientists have been telling us that if we have a nuclear war, it's going to be like the year without a summer, which was caused by a volcano. And agriculture was failing because of all this stuff being put into the atmosphere. And if one volcano can do that, a nuclear war could certainly make it worse. Yeah. So he understood it, which is quite surprising to people who were there at the time, but he definitely understood it. And Gorbachev, likewise, after the event, said, Russian and American scientists, he put Russians first because he believed Russian scientists could care less about American scientists. But Russian and American scientists are telling us, that you can't win a nuclear war, and so people of morality and judgment, realize we have to do something about this. He was much more eloquent than my paraphrase. But nevertheless, Reagan and Gorbachev did agree to do something. And every American president and every Russian president since then has reduced nuclear arsenals. Unfortunately, in the Trump administration, he walked away from the treaty that those two presidents had created.
Of course.
Partly because he thought the Russians were violating it. The Russians now have thousands of tactical nuclear weapons that they can use against Europe. This is a real danger that I don't think Europeans are aware of. There's a huge Russian arsenal that's meant to carry nuclear weapons all over Europe with airplanes, with cruise missiles, with conventional missiles. This is very, very dangerous. But nevertheless, my point is that at that time, leaders that you wouldn't have thought would pay attention to you, given what was going on at the time, did actually know what was going on, and they had paid attention to it, and they knew they had science communities in both the United States and Russia and elsewhere that told the leaders that, they didn't need 70,000 nuclear weapons. And, it was ridiculous.
Yeah.
We don't need 8,000 nuclear weapons, I already said.
It's like someone saying, I have 9 guns at home to defend my family.
Yeah, right. More like 900. And some explosives too.
Yeah.
And so they did something, and that had a big effect. And not only did Russia, the U.S. build them down, but other countries stopped trying to make nuclear weapons or got rid of the ones they had.
Yeah.
And 5 or 6 years later, the Soviet Union disintegrated, and the Ukraine and a couple of other Soviet states gave their weapons back to Russia, got rid of them. So it appeared for a little while in the early 1990s as if peace had broken out, and rationality was going to take over the earth, and we would solve our problems by debating and calmly discussing things. And I think that thought actually persisted for a couple of decades, and even Putin was excited about it in his youth, of the thought that Russia could be a normal European country and highly successful and things like that. And I'm not sure why he has changed his mind, but we're in a very dangerous position right this minute. And there's 3 reasons we're in a really dangerous position. One of them is there's a lot of nuclear weapons there. There's these 8,000 weapons, which could cause a nuclear winter and could kill most of the people on the planet. We're predicting a war between India and Pakistan could kill billions of people.
Yeah.
And a war across NATO could kill maybe 5 billion people. So that's very dangerous. The second thing that's very dangerous is that countries are not resolving their problems, which they could. I mean, there's no reason that India and Pakistan can't solve the Kashmir problem.
Yeah.
They should be able to sit down and solve that problem somehow.
There's too many egos being,
I don't know how they're going to solve it, but it seems to be, not being a politician, they should solve that problem instead of destroying each other.
Yeah.
And, Russia and the United States ought to be able to solve these other problems without having a nuclear war. And even Putin doesn't believe there's a nuclear war. Although he was saying things a few weeks or months ago that there could be a nuclear war over Ukraine. He just sent a message to the United Nations, which is having a review of nuclear weapons in the next few weeks.
Yeah.
He said, oh, well, a nuclear war can't be won and should never be fought. That's what he really thinks. The guy, Putin is not stupid.
Yeah.
He knows that Russia would be nothing but a smoldering ruin if there was a nuclear war. And he
doesn't want to destroy it.
Yeah, he doesn't really want to destroy that. But the other thing that's scary, and we have to do something about, is that there's a new arms race going on. There's an arms race between India and Pakistan, building up bigger and bigger arsenals. There's no reason that they need any more weapons than they already have.
Yeah.
They can kill 100 million people. What do you need?
Well, yeah.
But it's even worse in Russia and the U.S. Obama administration gave the Department of Defense and Energy hundreds of billions of dollars to go refresh the arsenal. They were supposed to patch it up and make sure it still worked. But no, they have to go out and build new weapons. That's what they're doing. And the Russians are building new weapons. And this is really scary. So right now what happens is it takes about 30 minutes for a Russian rocket to hit the United States. So what that means is that you can imagine President Biden, every Sleepy Joe, okay, he's not alert and attentive. You can imagine Joe's asleep because it's nighttime in the U.S. and all of a sudden Jill Biden comes running down the hallway saying, "Wake up, Joe, wake up." You've got 20 minutes to decide whether you want to end Western civilization by launching the rockets because the Russians have launched theirs. And
Whoa.
what is
And he's got that ball, you said, the one he carries, right?
He's got the briefcase. He can launch the weapons all by himself. No one can stop him. And he has 20 minutes to decide if this is a false alarm.
Yeah.
And there have been numerous false alarms in the past when people have thought there was a launch. And it's only just by luck that the other side waited and decided to make sure before they launched their weapons. So this is very, very dangerous. But we're facing something worse now because, Russia, for example, claims, and I think they actually do have, drone submarines. They call them torpedoes. The objective of which is to put a really big bomb on it and go put it in harbors around the world. And if they feel threatened, they blow them up. They just threatened the British with this. They put one of these things downwind of them and blow it up and spray radiation all over Britain. Then they also have hypersonic gliders that they've built. The point of the hypersonic glider is to have something that can shorten the times from 20 or 30 minutes to a few minutes. And that just makes it worse. You have no time to decide.
You can't even wake him up from bed.
Yeah, don't have time to wake him up.
Yeah.
And, then they also, a year or two ago, had a cruise missile blow up, which was a missile that's powered by a radioactive engine like a submarine is.
Mm-hmm.
And the idea is that the Russians would launch these things, they'd fly around in the atmosphere forever. And if they ever decided they want to start a war, they just push a button and they all go attack immediately. So you'd have these things in the atmosphere all the time, and they could just suddenly attack you. And the United States thought about building something like this a few decades ago, and it occurred to them, wait a minute, what if I want to land it? What if it doesn't work? It's got to come down and blow up, which is what happened to the Russians. So things did blow up. At any rate, where are we headed with this? We're headed to artificial intelligence. We're going to have artificial intelligence very soon start telling us whether we're under attack and whether we should respond. So I don't know about you, but my computer does not work well. I can't even get Zoom to work. My microphone doesn't work half the time. This stupid thing is constantly doing something wrong. Do I have any faith that artificial intelligence should be deciding for me that the country's under attack and we should launch our weapons? But that's going to happen to us if we don't do something about these new weapons that Russia and the US are building. We have to do something about that, or we're going to be run by machines, which is the other way the human race is thought to end, that the machines will simply take over from us when they get a little bit smarter than they are now. They'll decide they don't like us and get rid of us. We'll be like animals in the zoo they kept around to remember.
Yeah. Did you hear about that Russian chess robot that was competing with the 7-year-old chess? I don't know if he's a prodigy, but he was a chess champion. And apparently the kid made a really fast move and the robot just leaned over and broke his finger.
I heard that, yeah. That's just what we're headed to.
Yeah, with not chess, but the real game of chess.
Right. It's very scary. So people like you could do something about this. So what we have to do, this is what I'm doing, is telling people about this.
Yeah.
People aren't hearing about it. I did a TED Talk a few years ago, and 4 million people had seen it until about 6 months ago. Yeah. And it was like, I've been studying nuclear wars for 35 years, and you should be worried. And it was getting comments like, why are you studying this for 35 years? There haven't been any nuclear wars. What are you doing with your time? And it was derogatory kind of comments.
Of course, that's YouTube, right?
Now 8 million people have seen it. So twice as many people saw it in the last few months. And the comments are things like, I've been thinking about nuclear weapons for 30 minutes, and I am worried. So that's what we have to do. This is what happened in the 1980s. It was people around the world said, I've had enough of this. I'm tired of this going on. And the United Nations, for example, just banned nuclear weapons. So the countries of the world and the General Assembly voted to ban nuclear weapons, just like landmines and poison gases and chemical weapons are banned. And so their nuclear weapons are actually forbidden. You're forbidden to have them. You're forbidden to tell anybody else how to make one. But people are blind to this problem. It seemed like peace broke out. And that all the world's problems were solved. We could all be friends, and instead of wasting our, you can see this around the world, countries that are fighting and having civil wars, and I mean, they have no future. They're not prosperous. It's the countries that are democracies, and like India and Pakistan and the United States and Europe, those countries are not fighting, and they're very prosperous. And it's terrifying to look at Russia. If you look at North Korea, that's a failed state.
Yeah.
There's a dictatorship there. The people are starving to support one family in riches.
Yeah.
And instead of investing in their people, they're investing in their military and in maintaining their power. Russia is headed the same way. It's obviously not a failed state, but it's a failing state. Half of its economy comes from fossil fuels. We can't have fossil fuels in coming decades because of the greenhouse effect. The Russian economy is aimed in the wrong direction. They're not developing their economy on things that will sustain them. They're investing their money in missiles and bombs and invading their neighbors. There's nothing to be gained by invading your neighbors and having missiles and bombs. So we have to turn Russia around and, have them develop their economy in peaceful ways. They have a rich society there with a wonderful history and, spectacular achievements in the past. There's no reason they can't have spectacular achievements
people
in the
as well.
future.
Yeah.
But they're not going to do that by invading their neighbors and making more bombs. That's the wrong direction. And it's not like the United States is innocent about this either. We have our own problems, and we're building bombs too, and we need to stop it.
Well, I hope that, people listen to Sense and people to listen to people like you. And thank you so much. I think we can take it at this point to sort of, let the cockroaches celebrate.
Right. I have a few cockroaches around here. I'm sure they're...
Yeah, I can hear them with their vuvuzelas. But no, thank you so much for talking to me today. And I think, I, on behalf of everyone listening, I think for the great work you've done and dedicated your life to. Thank you so much, Brian Toon, for being here.
And thank you for inviting me to speak to you, and good luck with your program.
Thank you. Thank you, sir. Appreciate it.